Hello, everyone. Welcome to Lecture 6 on Introductory Statistics. In the last lecture, we introduced the three measures of center, the mean, the median, and the mode, and also two measures of variation. So one is the range, the other is the standard deviation. And we introduced how to calculate uh, all of them, and we stop here at the standard deviation. A general procedure for finding standard deviation. So we introduce these 6 steps, right? So you got to determine if the data set is a population data set or sample data set. And second, you need to compute the mean x bar for the sample, mu for the population. Three, subtract the mean for each individual value. So basically, this step is to find the deviation from the mean, right? And then step 4, square each of the deviations. And then step 5, add all these squares up. And finally, plug in the formula, right? So if it is a sample standard deviation, we have this formula. If it is a population data set, we have this formula. Okay, just be careful on that. Okay, so this is how we can find out the standard deviation. Now, let's consider an example. Consider this example. This is the nursing in training example. Here we have a sample of the times. Here's 10, 6, 5, 14, 6, and 13 in minutes. Now, we want to calculate the standard deviation. Now, how can we calculate the standard deviation? Now, firstly, we see that this is a sample, right? This is a sample data set. So this is going to be x bar, right? So for the mean, right, we found this mean in a previous example. And at that point, we found that the mean is 9.0. So we already found this mean, right? So compute the mean, we already found x bar. So in the previous example, so we don't have to do that again here. Okay, and then we want to subtract the mean from each individual value. So now to organize our calculation, we want to use this table. Okay, so in this table, in the first column, we're going to put all the x values. As you can see, I put in increasing order, but it doesn't have to be. All right, you can put in the original order if you want to, but make sure that you have all the values in the first column. So I have what, 5, 6, 6, 10, 13, and 14. So total 6 of them, right? So I have 6 values here in the first column. And in the second column, I want just to put x bar. That is the calculated mean. All right. And then in the third one is to find the deviation. So the difference between the individual value and the mean. Okay, so for instance, 5 minus 8 is -4, right? 6 minus 9 is -3. 6 minus -3, 10 minus 9 is 1, 13 minus 9 is 4, 14 minus 9 is 5. So in this column, we have all the differences. X minus x bar. And you can see that in the first step, we're going to take the square of all the deviations. Deviation here is the difference. Okay, so then be careful here is -4. The square of -4 is 16. Okay, the square of -3, 9, 9, 1, 16, and 25. So in the fourth column here, we got all the squares of the deviation, right? All the squares of the deviations. So this is our first step. In the fifth step, what do? Add them up, right? We add all the squares up, and we got This one is here, 76. Be careful in the calculations. All right, be careful in the calculations. So this summation is 76. Now what shall we do? Okay, just since this is a sample data set, we're going to use this formula. S equals square root of the summation of the squares over n minus 1. Okay, so this n, okay, we have n equals 6, 6 values, right? So n is 6, this summation is 76. So you can just plug in the formula 76 over 6 minus 1, and you find this one equals this. And you want to round it up to what? One more decimal place than the original data. So the original data are have no decimal places, so we round to one decimal place for the answer. Okay, so we got 3.9 minutes. Okay, so the standard deviation has exactly the same unit as the original value. So if the original value is in minutes, then my standard deviation is also in minutes. Okay, so that's how we calculate the standard deviation. So how to do that? It's better to use this table to organize our calculation. You got the first column, all the x values. Second column, put the mean. And third column is to find the deviation from the mean, right, for each value. And then finally, this last column is take the square of the deviations. Now you find all that. That is give us all the squares. And then you take the summation of all the squares. And then after you got all the values, plug in the formula. And you got a value. And finally, do round this answer into one more decimal place than the original value. So since the original value here, all these are integers, they have no decimal place. So our final answer will just have one decimal place. Very good. Okay, now let's consider another example here. Okay, listed below are annual salaries of 4 TV personalities in millions of dollars. Find the sample standard deviation. Here again, this is a sample standard deviation, right? So can you please go ahead and calculate this standard deviation? Okay, so can you do that? Similar like using the method we just introduced. Okay, so how to find the sample standard deviation for this one? So solution, right? So what we do is, I remember to draw the table here. Okay, to draw the table. So the first column is all the x values, right? So we put all the x values. So let's just say 15, 14, 13, and 12. And in the second column, you want to find the x bar. Okay, so x bar, which is the sample mean. So now, since we do not have the sample mean for this example, we got to find it here. Let's find the x bar here. So x bar equals summation 13 plus 12 over what? Over 4. And you can use a calculator. And this will give us, this is what? 13.5. 13.5. And you want to make this mean as accurate as possible. So this is already the exact value for the mean, right? So if it is a long decimal place, then you want to make it as accurate as possible, or simply use a fraction. Okay, so let's just put 13.5 here for the mean. So 13.5, 13.5, 13.5, and 13.5. I'm going to just put all the x bar here. Okay, so this is our x bar. And then you want to find in the third column is what? What is the third column? That is the deviation from the mean for each individual value. So here is going to be 15 minus 13.5. What do we get? Now you see that this is 1.5, right? And here is 14 minus 13.5, which is 0.5. And 13 minus 13.5. Here, be careful, is a negative 0.5, right? Okay, negative 0.5. And finally, 12 minus 13.5 is negative 1.5. Okay, so we have this. Now, finally, another column, right? So that is what? That is the square of the deviation, x minus x bar square. Okay, so we have this one is 1.5 square, 1.5 square equals 2.25. Okay, so here is a 0.5 square equals 0.25, and here is negative 0.5. Okay, be careful in a parenthesis. Square, okay, the square of negative 0.5. Okay, so using if you are using a calculator, make sure that you have this parenthesis. All right, so over what enclosed is negative 0.5 is enclosed by a parenthesis, and then you take the square. Okay, so here you found that it's 0.25, and finally similarly it's negative 0.5 square, and it is 2.25. Okay, so that's all the squares. Now, what shall we do next? Okay, very good. Take the summation, right? So we want to take the summation of all the squares. So let's see that. Summation of x minus x bar square is, okay, so basically take the summation of all these 4 squares, 2.25 plus 0.25 plus 0.25 and plus 2.25. So what did we get? This is 5.0. Okay, so this is exactly 5.0. Okay, so now since we already got the sum of the squares, okay, and also how many values are here? So we have n equals 4. So 4 values in total, right? So what's next? Next is simply using the formula, right? So since we have a sample data, this is a sample data, we're going to use the formula about the sample standard deviation. So let's do that. So S equals what? Square root, okay, the summation of x minus x bar squared over n minus 1. So we plug in here, so it is, and top is 5, here is 4 minus 1. And you can use a calculator to find out this value. Okay, so what did you get using the calculator? Okay, can you please find it? Okay, so it is square root. Okay, let me just use the calculator here. It is 5/3, 5 divided by 3, and take the square root. It's 1.29. I got 1.291. Okay, so 1.291. But you see, where shall we round this value to? Okay, so if you remember, we got to round this value into what? One more decimal place than the original value. Since the original value here are integers, so this one will round to what? 1.3. Okay, one more decimal place than the original value. Very good. This is how we calculate the sample standard deviation, right? So following these steps, we got it. Okay, very good. What's going on? Sorry. Oh gosh. Oh gosh. Sorry. Huh? Okay. Okay. Sorry about it. All right. There's something wrong with this. Okay. So we got this one is 1.3, and this is in millions of dollars, right? In millions of dollars. Okay. Very good. Now, let's consider this example. Okay, now here is the weights in pounds of all 5 snow leopards in one mountain range from Central Asia are found and listed below. Okay, so can we find the standard deviation of the weights of the snow leopards in this mountain range? Okay, so firstly, is this a sample data set or population data set? How do you think? Okay, so be careful. The word here are 5. Okay, so means what? Means that's only 5 snow leopards in this mountain range. Okay, so this is a population. Okay, so all the whole collection of all the objects of interest. Okay, so because it states that this is all the 5, so that is a population. All right, so okay, solution. It is a population. It's a population data set. Okay, so it's a population data set. Okay, now what shall we do? So first step, we are going to find out the mean. So what is the mean? So we are using what? Since it's a population data set, we are using mu as the population mean. So it equals the summation of all these values, 55, 72, 80, 58, plus 86. Over 1, 2, 3, 4, 5 over 5. Okay, so can we find this value? Let's use the calculator to find all these values, right? So 65 plus 72 plus 80 plus 58 plus 86. Okay, so we got this summation is 361 over 5. Okay, so and then divided by 5. Okay, so I got is 72.2. Okay, 72.2. This is the mean, right? This is the mean. Now, everything else will be similar, right? So let's just do this one here. The first column, okay, it's going to be our 65, 72, 80, 58, and 86. And the second column, we are going to use the population mean, which is our mu. Okay, we are going to put a mu here. All right, so 72.2, 72.2, 72.2, 72.2, and 72.2. Okay, all right, so that's the second column. We put the mean out there. All right, so then in the third column, what we're going to do is we're going to put x minus mu, right? The difference between the x and mu. Okay, so the first one is going to be 65 minus 72.2. So this one is negative, right? 7.2. 7.2. Right? So here is 72 minus 72.2, so which is negative 0.2, okay? And 80 minus 72.2, so this is 7.8, okay? Now 58 minus 72.2, so what do we get? Okay, minus 14.2, negative 14.2, okay, negative 14.2. And finally, I have 86 minus 72.2, so that is 13.8, right? 13.8. Okay, so we got all the differences. Now, the last column is going to be the square, okay, of the deviations. So the first one is going to be negative 7.2 parentheses square equals, okay, 7.2, take the square. So I got 51.84. Okay, 51.84. Now, be careful. I'm not rounding it here. Right? I'm not rounding it here. Okay, because I'm in the process of getting the value of the standard deviation. I want to be as accurate as possible during the process. Okay, so at this point, I'm not rounding it. Okay, I want to use as accurate as possible values. Now this is a negative 0.2 square, so which is 0.04, and this is 7.8 square, so 7.8 square, so 60.84. Okay, this is 60.84, and this is negative 14.2 square, so this is 14.2, take the square, and I got is 201.64. And finally, it's 13.8 square. So 13.8 square, I got 190.44. Okay, so these are the values of the squares. Now, what shall we do? So we're going to plug in the formulas, but which formula shall we use? It is for the population one, right? So it is this formula. Here, we already found the sum of the squares. The only thing we need to know is the capital N. So where capital N is what? Capital N is the population size. All right, so here we also have N is 5 of them. So capital N is 5. So the population standard deviation sigma equals, by the formula, it's a summation x minus mu square over what? Over capital N. Be careful, we do not minus 1 here, right? So for the population version. So then we plug in all the values here. Oh, okay, so we haven't found the summation yet, right? So let's calculate the summation. So I'm going to put it here. So the summation of x minus mu square, so is what? The summation of all these squares. So let's get the summation of all the squares. 81.8 plus 0.04 plus 60, sorry. Okay, well, okay, clear. Okay, so 51.8 plus 0.04 plus 60.84 plus 201.64 and plus 190.44. And I got this summation is 504.74. Okay, so once you've got the sum of the squares, then you can put 504.74 over 5, right, over 5. So this one equals what? Okay, let me just put it here. This one equals, divide by 5 and take the square. Okay, so I got is 10.0475. Okay, now we got to round it to what? One more decimal place than the original value. The original values are integers. There's no decimal place. So we got to round it to one more decimal place, which is 1 decimal place. So it's 10.0. Okay, so this is in pounds, right? So in pounds. Okay. All right, so here is the population version, right? So how to find out the standard deviation of a population. So which is a little different from the sample version, right? So, but the procedure is very similar. Okay. All right, very good. Now, here is some interesting use of the mean and standard deviation. So, which is called the range rule of thumb. Okay, what is that? Okay, so here is the range rule of thumb is a crude but simple tool for understanding and interpreting standard deviation. Okay, so given a sample, you can find the sample mean and also you can find the sample standard deviation. Okay, so and then the range rule of thumb states the following: the vast majority of the sample values lie within two standard deviations of the mean. So what do we mean by two standard deviations of the mean? So that is in the interval, right? Two standard deviations below, two what? Two standard deviations above the mean. Okay, so that we say the vast majority will lie within this range. Now, there are, this range rule of thumb has many interesting applications, especially in the production line. So in the quality control. Let me just give you a simple example on this. Say that you have a laboratory work, okay, so which requires a certain pressure and a certain temperature. Let's say that certain temperature, right? So in order for this to to be normally function, right? To act function normally. So you need what? A certain range of temperature. So what you can do? So you can, based on using the same historical data, find all the means, right? And find the mean and also get a standard deviation. So you would say, all right, so the temperature should be within what? This two standard deviations, the mean within this range for majority of the time, right? So you will claim that okay, if it is within this range, then everything should work okay, work normally, right? Okay. And then what if somehow the temperature is outside this range? For instance, it's too hot or too cold or without this range, then that means what? That means there might be something wrong with it, right? So there might be something wrong with it. So you need to know in order to guess that um, in order to get this tool or this range, you would need to use what? The sample mean and also the sample standard deviation in order to find this, right? So yeah, this is an interesting application of this range rule of thumb. So by using this range rule of thumb, we have the following definitions. So for significantly low values, okay, so those are the values, two standard deviations below the mean or lower. Okay, that's significantly low. Okay, two standard deviations below the mean or lower. Okay, now significantly high values or those values are two standard deviations above the mean or higher. Okay, now finally, these are the values within the two standard deviations of the mean. Okay, that should be the vast majority. Okay. All right, so here are some important properties of the standard deviation. And one, standard deviation is a measure of how much the data values deviate from the mean. Okay, as we can see from the calculation of the standard deviation. So we're taking the deviation or the difference between individual values and the mean, right? X minus X bar or X minus mu. So that is to say standard deviation is a measure of how much the data values deviate from the mean. Second, the value of the standard deviation is never negative. It's never negative, right? Because it's a square root, right? So how can it be negative, right? So it's not never negative, and it is 0 only when all the data values are exactly the same. So when all the values are exactly the same, they are all the same. There's no variation among them. So the standard deviation is 0. Okay, in another way, if the standard deviation is 0, which means what the sum of the squares are all 0. So which means all those squares are 0 and all the deviations are 0. So they are all the same. And larger values of S indicate a greater amount of variation. So the larger, the more variation. And standard deviation is can increase dramatically with one or more outliers. So because it utilizes every single value and outlier, it was greatly affected, it's very sensitive to outliers. Okay. The units of the standard deviation are the same as the unit of the original data set. Okay, like we showed in the previous examples, if the original data set is in pounds, then the standard deviation is also in pounds. If the original data value is in minutes, then the standard deviation is also in minutes. Okay, and so on. So they share the same unit as the original data values. And finally, this says the sample standard deviation S is a biased estimator of the population standard deviation, which means the value of the standard deviation, sample standard deviation does not center around the value of sigma. Okay, that's not a value around there. Okay, so well, this is this idea of biased estimator is out of the scope of this course. So we're going. This is just for your information. Okay. All right. So here is some important. These are the important properties of standard deviation. Now let's move on to next the variance. Okay. So what is the variance of a set of data? So the variance of a set of data is a measure of variation that equals to the square of the standard deviation. So after you find the standard deviation, just take the square, then you got the variance. Okay, so for sample variance, it is the square of the standard deviation S, sample standard deviation S. Population variance is the square of the population standard deviation, sigma. Okay, so here are some important properties of the variance because it is the square of the standard deviation. The units of the variance are the squares of the units of the original data value. Okay, because when the standard deviation share the same unit of the original value, now your variance is the square of the standard deviation. So therefore, the units of the variance are going to be squares of the units of the original value. So this is the first property. Secondly, the value of the variance can increase dramatically with inclusion of outliers. So it is not resistant to outliers, okay, to significant extreme values. It is very sensitive. Okay. So the value of the variance is never negative. Okay. This is the same as what? The standard deviation, because the standard deviation is never negative. You take the square of the standard deviation. Now, of course, it's never negative, and it's 0 only when the values are the same. Now, finally, here, the sample variance is an unbiased estimator. Okay, again, this is out of the scope of this class, so we're not, this is just for your information. Okay, now let's just, since the variance by definition is just the square of the standard deviation, let's find the variance for the previous examples. Now, for instance, this one, okay, the weight in pounds, all right, snow leopards. So what is the variance? So what about the variance? The variance equals what? Equals the square of equals s squared. Okay, equals s squared. Now in here, there is one thing I want to mention is you want to use the accurate value instead of the rounded value to calculate the variance. Okay, because you want to have more accurate values for the variance. Now sometimes you will round it, then take the square, it might be something different. Okay, so use the more accurate value of the standard deviation in the calculation of the variance. Now let's do that. So it's 10.0. Okay, so I'm going to use 10.0475 squared. Okay, I'm not using 10.0, even though they may got the same answer, but I prefer at this point using the more accurate one. So, oh, sorry. So this is should be what? Should be the population. Right? So should be the population. So it's a sigma square. Okay, sigma square. Okay. So that's 10.0475. Take the square, and I got 100.9. Okay. So 100.952. Okay, so then you round to one more decimal place. Okay, so you will get what? 101.0, right? 101.0. Okay, so this is going to be the variance. You see the difference, right? So if you're using the rounded value here, 10.0, you got 100, right? You got 100, but that's not very accurate. You want to use what? The more accurate value of the standard deviation to find the variance, the non-unrounded one. Okay, so the exact value here. Okay, then you find that this is 101, right? 101.0. Now, similarly, let's do this one. How about this? What is, we found the sample standard deviation. So can you find the variance? Okay, what is the variance? Okay, so the variance will be what? The variance equals, this is a sample data, so it is, notation is s squared equals, take the square of which one? Which one do you take the square with? So you're going to take the square of this one, right? So the more accurate value, 1.291 squared. So this will give us what? Okay, I got 1.667. Now I want to round to one more decimal place as well. So it's 1.7. Okay, so this is going to be the variance. All right, this is going to be the variance. And finally, let's do this one. All right, let's do this one. So what is the variance? The variance, again, you want to, it's a sample data set. So the variance is a sample variance, which equals s squared. Now we're going to use what? 3.899, 3.899 squared. So what did you get? 3.899. So sorry, 0.899 squared. So 15.20, 15.20, sorry, 2022. So this will round to 15.2. Okay. Now this one, the unit, okay, unit will be what? The minute, square minute, or minute square minute. Okay, so it is the square of the unit of the original data. If this is in minutes, then that's a square minute. Okay, square minute. And this one, if it is in pounds, then this 110 is square pounds. Square pounds. Okay, so that's the unit of the variance. All right, so very good. Now here is the link for if you want to use the TI-83 or 84 for these descriptive statistics. You can follow this link to watch all the instructions on that. Okay, so this will give you some idea on how to calculate these descriptive statistics using calculators. Now, TI-83 or 84. Now, of course, if you're using other versions of calculators, you can Google it and find other methods. Okay. Now, for this course, you need to know how to calculate the values of the standard deviation and variance and the mean, median, and so on by hand. At least you need to understand all the procedures and why and how to calculate those values. Okay, instead of just using the calculator. Okay. Now, let's move on to section 3. It's the measures of center and variation for grouped data. Okay. So firstly, let's talk about the mean of grouped data. Okay. Now, again, let's consider the nursing training example. Now, we take 36 observations from the nurse. Only now, instead of recording individual times, we only have the following frequency distribution table. Okay, it's a grouped data, right? So we know that this is a frequency distribution table. We only know that these are the categories and what? The corresponding frequencies. We only know that there are 6 among 3, the first category, 11 of them are within the second category, 7 in the third, 9 in the fourth, and finally, there are 3 data are within the range 15 to 17. Now, if we are given such a table instead of the original values, how can we calculate mean? This is a grouped data, right? So we do not know the individual values. Now, for instance, we may know that there are 6 values, right? 6 values in between 3 to 5, but what are they? What are the individual values of these 6 values? Right? So we do not know. We only know that they are within this range, but as far as what exactly they are, we have no idea. So in order to calculate the mean, you got to take the summation, right? The summation. What is the summation of all the values that you have? Now here you do not know where exactly they are, so it's impossible to get the summation. And of course, the mean, right? So now in such a way, okay, when the data is grouped, the identity is lost. We cannot retain the original values. It is impossible to obtain the exact mean. We can only get an approximate value for the mean, right? Approximate value, not exact value. So what we have to do is we can find how to find the approximate value for the mean. So we can do using the following procedure. And the first is find the class midpoints. So remember what are class midpoints? So we discussed this one when we talked about frequency polygon, right? So how to construct a frequency polygon using a frequency distribution table. Right. At that point, we talked about class midpoints. So what are they? What they are by what? The averaging the upper and the lower class limits of that class. Now, for instance, here, right? So the lower class limits for the first one, right? So it's 3. Upper class limits is 5. So the midpoint, so it's going to be 3 plus 5 divided by 2. Take the average of these two. So which will give you 4, right? Now for this one's 12, 14, this class. So the lower limit is 12 and upper limit is 14. So divided by 2, you'll find that it's 13. So 13 is the midpoint for this category, for this class. So we can find the class midpoints for each class or category by averaging the upper and lower class limits of that class. Second, we want to multiply each frequency and class midpoints and take the product of frequency and this midpoint for each class. And third, then add all the products and add all the frequencies. Find the summation of the products and summation of the frequencies. Finally, divide the sum of the products by the sum of the frequencies. Okay, so that will give us an approximate estimate of the mean. Okay, now let's show how to find this approximate mean by using the following example. Let's demonstrate how to do that. Okay, so again, this is the frequency distribution table we just talked about, and let's show how we can find the mean. Okay, so what we do is you can add another column here to list all the midpoints. Okay, so what is the midpoints for the first one? As we calculated, this is 3 plus 5 over 2, right? So equals 4, right? And this one is 6 plus 8 over 2, so which is 7. 9 plus 11 over 2 is 10, and 12 plus 14 over 2 is 13, and 15 plus 17 over 2 is 16. Okay, so we got all the midpoints listed here. Next is to find the products, okay, which is the midpoint times the frequency, x times f. So x here is 4 by 6, that's 24. 7 by 11, that is 77. 10 by 7 is 70. 13 by 9, 117. Yeah. So, and 16 by 3 is 48. Okay. So we got all the products as well. And then what is the next step? Okay. So is add the products, add the frequencies. Okay. So for the products, add all these products up. So what did we get? All right, let's use a calculator to find the summation. So 24 plus 77 plus 70 plus 117 plus 48. And what did you get? I got 336. Okay, and then for the frequency here, you add up all these frequencies. So what do we have? So 6 plus 11 plus 7 plus 9 plus 3. So got 36. Okay, 36. Okay, so therefore the mean is what? The mean using the formula, as we know, is to divide the sum of the square by the sum of the frequency. So 336 over 36 equals, okay, so 336 over 36, 9.333. Okay, I got 9.333 3. Now, we want to round this one to one more decimal place than the limits. Okay. So you want to round it. Okay. So one more decimal place than the class limits. Now for the class limits, we have 3, 6, 9, 12, 15, 5, 8, or the lower class limits, 5, 8, 11, 14, 17, or the upper class limits. 0 integers, right? So no decimal place. So therefore, we round the final answer into one decimal place, 9.3. Now, of course, this is also in minutes. Right? In minutes. Okay, so this is how we do so, right? So for grouped data, even though we do not have the exact values, but we can find an approximate one by doing what? Firstly, find all the middle points, and then find the products, find the summation of the products and the summation of the frequency, and plug in to the formula, and you got this value, right? So very good. Okay, so this is how we find the mean of a grouped data. Now, could you please try out this example? Okay, so can you find the following table is the frequency distribution table of mass in kilograms of 40 students in a class of introductory statistics. We want to calculate the mean. Can you calculate the mean for this one? So what shall we? Okay, so be careful following those steps, right? So you need to find out the class midpoints, the products, add up all the products, add up all the frequencies, and then divide them, right? So can you solve this problem? Okay. So let's just add another column, midpoints. Okay. So now here is the 40 is the lower one, 49 is the upper class limit. So the midpoints is what? 40 plus 90, 40 plus 49 divided by 2, and this should be what? 44.5. Okay, similarly, this is 50 plus 59 over 2, which is 54.5. And similarly here, 60 plus 69 over 2, that's 64.5. And 70 plus 79 over 2, that's 74.5. Finally, 80 plus 89 over 2. That's 84.5. So we got all the midpoints, right? And then what do? Now we find the products. Right? So all the products, that's what? XF. Okay, so X are the midpoints. So 44.5 by 3. Now you can find this value, right? 44.5 times 3, and is 133.5, and this is 54.5 times 8. Okay, so 54.5 times 8. So I found this is 436, and 64.5 by 14. So 64.5 times 14, so 903. And 74.5 times 13, 13. Okay, so this is 968.5. And finally, 84.5 times 2. Okay, 169. Okay, 84.5 times 2, so 169. Okay, so we got all the products now. Now, what do we do next? Okay, is to find the summation of all the products and summation of all the frequencies. So what is the summation of the products? So take the summation of all these values. Now let's do that, right? So 133.5 plus 436 plus 903 plus 968.5 plus 169. Okay, so what did you get? I got this summation equals, right? This summation equals 260, 2,000, 610. Okay, so this is the summation of the products, and then we also need a summation of the frequency. That's the total frequency equals what? Let's add them up. So, well, we already know this total. It's 40, right? So basically, the summation is just 40. Okay, very good. All right, we got the summation of the products and summation of the frequencies. Now, the mean is what? Okay, so by the formula, we know that the mean is the summation of the products over the summation of the frequency. So over 40 equals divided by 40. So what did you get? Okay, 65.25. So do we have to round it? Yes, right. So here you have the limits are integers, right? So integers. So we're going to round it to what? 65.3. So one more decimal place in the class limits. So this is in what? In kilograms. In kilograms. Okay. All right. So that's in this example how to find the mean of grouped values. All right, grouped values. Very good. Okay. Now, next we're going to show how to find the standard deviation of grouped data. Okay, so you have what? The mean of grouped data and also the standard deviation of grouped data. Now, how to calculate this one? Okay, so we're going to use this formula for the sample version. Okay, so it is this one. N times this one minus it's a complicated one, right? So where X are the midpoints of different classes, F are the frequency, and N is the total frequency. Okay, now let's show how to calculate this value. Right, it's a complicated formula here, right? Using the following 4 steps. Now, step 1 is to find the midpoints. You want to find the midpoints. Step 2 is you want to find the products XF and square of X times F for each class. Okay, because what? We have a summation here of the products X square F. Okay, you want to find that as well. And then you want to add the frequencies and the products XF and the products what? X square F. Okay, now you can find the N is summation of F. What? You also have add these products, so that then you got what? The summation of XF, and this finally the summation of X squared F. Okay, so you got all these 3 summations. After you got all these summations, simply plug in the formula for this one. Okay, this standard deviation for the group data. Okay, now let's show how to use these steps to find the standard deviation of grouped data. Now again, consider this example. All right, so we have 36 observations in nursing in training. We want to calculate the standard deviation. Now again, this is just a frequency distribution table. We do not know the exact values. So what we have to do is using the formula here. All right, so now what we are going to do is firstly find out what the midpoints and then so on, right? So let's show how to do that. Okay. Here we have this table. We want to add the column for midpoints, the products XF, and finally the product for X squared F, right? So another column for another product X squared F. So I believe we already have this in this column in one of the previous example when we calculate the mean, right? You see that? Okay, so this is the midpoints and this is the products. We already found all these summation as well, right? So basically we just want to add another, we can just add another x squared f, right, as another column, and then we can follow the procedures, right? So everything is given here, so we can just use the previous example. Now we have this one, midpoint is 4, 7, 10, 11, oh no, 13, and 16. Okay, so these are the midpoints and the products. This is 24, and this is 77, this is 70, this is 117, and this is a 48. Okay, so this is the products XF. And finally, you need to find out the product X squared F, right? So be careful here. It is taking the square of X and then multiply the frequency. Okay, so you have to be careful which is X, which is the frequency. Now we know that these midpoints are the X values. So in other words, it's 4 squared times 6, right? So you want to calculate that, right? Let's do that. 4 squared times 6. So I got this is 96. 96. Now be careful. It's x squared f. It's not f squared times x. All right. If you use what 6 squared times 4. Now 6 is f. This is x. So you're taking this one. So this will not right. Will not be right. Okay. So be careful. It is x squared times f, not f squared times x. And then here is going to be the second is 7 squared times 11. Okay. Okay, it's 539 and 10 squared times 7, which is 700, and 13 squared times 9. So 1 times 9. Okay, 15, 21, and 16 squared times 3. So 16 squared times 3. So 768. Okay, now we want to add all the frequencies together. So this is about our total frequency n. So we know that this is 36. And this summation we already calculated is 336. And lastly, this one is what? 96 plus 539 plus 700 plus 1521 and plus 768. Okay, so found that is 3,624. Okay, and then you just plug in this formula and see what we get. Okay, so n is 36 times, this is summation of the x squared f, is 3624 minus, the summation here is 336 squared over n is 36 times 36 minus 1. Okay, so now let's check the square on the top. All right, the top is what? 36 times 3624 and minus 336 square. Okay, so what did you get? Okay, so on the top, I have 17,568. Over the bottom, it's 36 times 35, so 1,260. Okay, so you can find this one, right? So that's 17,568 over 16. Take the square root. I got 3.734. Okay, again, you want to round one more decimal place than the limits. So the limits are integers, so we want to say 3.7. Of course, this is in what? In minutes. In minutes. Okay. All right. This is how we calculate the standard deviation of groups data, right? So find the middle points, product xf, products x squared f, and add them up, and then plug in the formula. Now, as you can see, there's a lot of calculations involved. Now, be careful in the calculations. Okay. All right. Now let's consider another example. Okay, so consider this example. All right, we just did this example before for the sample mean, for the mean. Now, can you find the standard deviation of this frequency distribution table? Okay, so can you find it? Okay, so what we can do is what? Okay, so this is going to be a lossy calculation, right? So would you please go ahead and calculate this value? Okay, let me just add here the midpoints. Okay, and you want to have product xf and x squared f. So we already found these midpoints and xf in a previous example. If you can see here, so yes, this one, right? So we already found all the midpoints and this product. Okay, so now we need another column, right, for x squared times f. Okay, so midpoints here is 44.5, 54.5, 64.5, 74.5, and 84.5. XF, oh gosh. Okay, well, let's just do that again. Here, 44.5 times 3. 44.5 times 3. So 133.5. 54.5 times 8. 436. 64.5 times 14. Now 3. And 74.5 times 13 is 968.5, and finally 84.5 times 2 is 169. Okay, and this is the product, and then another product is square f. Okay, so I'm going to write down as what? This is 44.5 square times 3. It is x squared times f, right? So be careful on that. Square times 3. So what did you get? Well, it's a large number, right? So 5940.75. Okay. Second is 54.5 squared times 8. Okay, 54.5 squared times 8. Okay, even larger, this one is 23,762. Okay, this is 64.5 squared times 14. Okay, 64.5 squared times 14. Wow, 58,243.5. Okay, and this is 74.5 squared times 13. Okay, wow, 74.5 squared times 13 is 72,153.25. Okay, and then lastly is 84.5 squared times 2. So square times 2, okay, 14,000 to a 0.5. Okay, so we got all these, wow, large numbers, right? So then what do? We take the summation of f, that is our n, this one equals what? 40, right? Equals 40, and sum of the midpoint, sum of the first product, I think we already found this one in the previous example, is, okay, let me see, what is that? That's okay. This one, 2610. Okay, it's 2610. Okay, 2610. And what is next? Okay, so these are large numbers, right? So let's add them up. 59, 40.75 plus 23, 762 plus 58, 243.5 plus 72, 153.25 plus 14, 280.5. Okay, I got 174,380. Okay, so this is what I have. What do we have? Okay, so I have n, this, and this. Then you can find that this is by plugging in the formula. Okay, on the top, that's n summation x squared f minus the summation xf squared over n times n minus 1, right? And n times n minus 1. Okay. All right, so this one will equal, okay, plug in all the values here. So on the top, n is 40 by this value here, 174,380 minus 2610 squared over 40 times 40 minus 1. So this equals, okay, this equals times 40 minus 2610 squared. Okay, so what did you find? This one equals square root of, okay, 104.551. All right, so, and then it is, okay, take the square root of that. It's 104.551, take the square root. Okay, I got this is 10.225. Okay, and then you round to one decimal place, it's 10.2. Now, of course, this is in kilogram, right? In kilogram. Okay, so this is this example on calculating the standard deviation of grouped data, right? So what do? We found the middle points, find xf and x squared f, and then find all the summations, plug in the formula, right? So that is how we can calculate, we can find out the standard deviation. Okay, all right, very good. Okay, very good. This is how we do so. And next we are going to talk about is the modal class. Okay, modal class. So what is a modal class? Modal class is a category that contains the most values, or with the category with the highest frequency. Okay, with the highest frequency. Well, be careful. It is a category. It is a category, not a frequency. It is a category with the highest frequency. Okay, so in case there are multiple classes, now with the most values, they are all modal classes. Okay, consider this is a simple example here. In this example, nursing training example, what is the modal class? What is a modal class? Okay, is that 11? 11 is the highest frequency, but the modal class is a category with the most value, with the highest frequency. So the modal class is a category. Okay, so it is what? 8 to 6 to 8. Okay, be careful since what? This category 6 to 8 has what? The most values. There are 11 of them, right? So therefore the modal class is 6 to 8. Is the class 6 to 8. The modal class is a class, right? So 6 to 8. Okay, be careful. It's not the frequency. It is the class with the highest frequency. Okay, now for this one, what about this one? So what is the modal class? Okay, very good. All right, so this 14 is the highest frequency. So the modal class is what? 60 to 69. Okay, all right. Okay, very good. In today's class, we talked about measures of like standard deviation and variance for exact values, and then we introduced what? The measures of center and variation for grouped data. Okay, and also here is the modal class. Okay, all right, that's all for today for this lecture, and I will see you in the next one. Thank you.